Hi, good morning. Today we'll discuss about software engineering principles. So before going to that, let me take you to a small discussion related to what is basically a software. The software in the traditional olden days, we will be considering that it is a set of instructions which will perform a specific task. But now in the recent days, the software has changed his definition, software has changed his role, and as well as software has changed his characteristic features also. And now in the today's era, this software takes on a dual role. So that means to say this software is a product, and at the same time it is the vehicle for delivering a product. So when I say it is a product, say nowadays whatever we are now seeing, most of the products that we use in the network or in the web or in the internet, so anywhere all these are products. Suppose if I take a bank application, right, if I take a railway reservation system, or if I take the portal which you are now seeing, so all these are products, and the product itself is a software. And now to generate this product and to achieve this, so we need some platform for development. And that's why I am saying that platform is a vehicle for delivering this product. Say if you consider this, there are so many languages are there nowadays. Say for example, if you take Java, so through the Java language, so we can develop a product, and the Java itself is developed through some language. So that's why it is being called, nowadays the software is being called, it is nothing but the software is both a product and as well as the vehicle for delivering a product. And now as a product, what it can do, it can deliver multiple things, right? It can be a computational potential body for a computer hardware, or it can be accessed by a local hardware or anything. So software is both a vehicle and as well as a product by itself. And now the traditional, come back to the traditional way of defining a software. See, there are, we can consider this software as three characteristics, or I can define this software in three terminologies. So one is a software is an instruction that when executed provides a desired function and a performance. So this is the traditional one which we already familiar with. And now the software is again a data structure that enables programs to adequately manipulate the information. Yes, now this is a new one. Say the software is now, it is a kind of data structure that enable the programs to manipulate the information. See, nowadays information is ruling, right? Whatever we have, the most of the applications are working on the information. So it is a kind of one, so which will manipulate the information. And also the software is a document that describes the operation and use of the programs. So we can define the software in this manner. And coming back to what are the basic characteristics of the software? See, in a traditional way, every product is manufactured, but the software, though we consider this as a product, this product is not manufactured, but this product is being developed or engineered. So there is a quite lot difference between manufacturing and engineering. See, manufacturing means that you will take the raw material, and these raw materials are generated or it is manufactured in somewhere, and you will assemble that in one place, and then you will be generating a product. Say for example, I want to develop a car. So if the car can be generated or the manufactured by assembling or manufacturing different already manufactured parts like engine, steerings, right, chassis, wheels, like this. Unlike this, the software is engineered. That means here everything is going to be generated from the scratch. That means we will be developing each and every part, that is nook and corner will be developing, and then it is been engineered. That means we will be combined into one single unit to make it as a product. And another feature is software doesn't wear out. See, every product when it is in use considerably to be weared out, depreciation, there will be a kind of depreciation. But when it comes to the software, ideally, I'm speaking about ideally, the software doesn't wear out. So wear out means even if you use the software in the idealistic conditions, considering there are no external factors applied on this software, so the performance of this will never be ruled out or never will be degraded. So whatever the performance at the day one, the performance of the day n will be the same, right? So likewise, the software doesn't wear out. Then next one is, although the industry is moving toward component based assembly, most software continues to be custom built. So custom built, say, uh, based on the requirement. You see the softwares. When I say the products will be of different different features, and that can be used by anyone. But this product is mostly custom built. Mostly custom built means based on the customer requirements, we are developing these products, generalized products. Right. Of course, in the normal terminology, we call these two categories as a product and a project. So basically, we call project as the one which is delivered, the software which is delivered as per the a specific customer requirement, and product is the one which is created or generated for the generic purpose, right? There is no specific customer targeted to it. There are a group of people who can use it in general. Say if you take operating system, so those operating systems are the products, right? And if you take any particular application, like say ICICI bank application, so it is a product. That means I am specifically targeting to my ICICI customers only, not to any others. So like this, olden days, these are things. But now, mostly the product is considered to be, the software is considered to be as a custom build. So these are the three basic characteristics that a software has. So it is developed, not manufactured. It will never wear out, and software is mostly custom built. Right, and now this is a small diagram which will depict the wear out. See, initially this model, whatever we are seeing is called a bathtub model. So in this bathtub model, the curve here depicts the high failure rate whenever the software is just installed. So this high failure rate may be due to many reasons, because of uh, the user's inability to use, or because of the environment which it has been deployed. So depending upon the factors of the internal factors, mostly because of these technical reasons, the failure rate will be very high. And as the time passes on, due to the accustomance of the customer towards the product, the failure rates will gradually come down, and it will reach us to a steady state, right? So this flattened curve indicates that with respect to the time, there won't be any failures. It will reach us to a minimized state. And now, because of the external factors like the hardware, see, though the software is not wear out, hardwares will wear out definitely. And ultimately, any software need to be deployed on any hardware device. So because of that external environment, the hardware failures or any hardware related issues, again, the wearing out will increase. So this is an ideal situation, right? In the ideal situation, say this curve depicts how this software wear out can be deployed or represented. But in reality, this curve will be like this. That means this failure will be very high. So slowly it will come down. It will come down to a normal point, and suddenly, if there is any change internally implemented inside the product, then this failure rate will again increases. And slowly after that change has been accustomed by the users, slowly it will get down and it will try to merge with the actual line, that is the normal ideal line. And again, if there is any change internally observed, say for example that change may be anything. Say let us take a simple example, like say I'm using one database with MySQL. So initially, I found some problems with MySQL, and I adjusted with that, and I came back the usage of that into a normal state. Suddenly, the developers are, due to some reasons, that is being changed to Oracle. So there is a sudden change here. So again, the problems will go high, right? And then after that, as the time passes on, due to various reasons, it will come down again to a smaller depreciated normal curve. And again, if there is any change, it will go up, it will go down, it will go up, and it will go down. So like this, these kind of things will observe in our software. So ideally software doesn't wear out, meaning in the idealistic cases it won't wear out. But due to the external factors, or due to the hardware failures, or due to some other external dependencies, it may try to fail. And how far it will fail, that depends on how frequent the changes that you are applied on that. So this is the thing that we need. And now the important task or important thing that related to the software development is the process. See, what is the process that we follow for developing any product? See, it is not only for the software product or the project. This process is a general term which will be, this will be important for any kind of development. See, the approach or the phenomena that we follow to achieve one particular task will mainly considered to be the essential factor for achieving the high quality. Say, if I want to develop or if I want to construct a house, or if I want to manufacture one car, or simply to say, if I want to cook a good food. So all these depend on the process. So what is the process that you need to follow, or what is the best practices that you need to follow, right? And based on this, your quality of your product or the quality of the output is defined. So this process or this selection is dependent on various factors, right? Like who does it, and why this is important, and what are the steps to be followed, and what is the work product that we need to require, and how do I ensure that I have done it right. So these are the different things that we need to consider while following any processes. Now, in our software, basically we'll follow some process for developing any uh, application, or for developing any kind of product. So this process defines how to generate one particular product. So it is a cyclic one. Basically, this process is a cyclic one, and we call this as the software development stages. Each stage performs one specific set of operations which will move towards the end goal. See, initial phase or initial stage, we call it as the status quo. Then we'll go to the problem definition. Then we go to the technical development, and then we go for the solution integration. And that solution will give a status quo for the next level. Say, for example, I want to develop one simple application, right? I want to develop one simple application which makes the automation of my office processes, right? The status quo defines the current situation, right? The exact current situation of your task. What exactly now manually doing, or what exactly the operations which are doing currently. So whether it may be a manually, or it may be an automated one, whatever it may be, the current situation. It speaks about the current situation. See, from that current situation, you need to define the statement. See, what I need to implement from this situation. So depending on the customer requirements, I need to specify what is my problem to be defined, or what is my things to be implemented. So once you define the problem definition, then corresponding to that, we need to go for the technical development. See, there are so many aspects involved in the technical development, like see the generalized problem statement, right? Say for example, let us take bus reservation, bus booking. See, let us assume initially they are doing this manually by taking a chart like structure. That means in this paper there is a piece of paper they are using, and on that, for each bus they are maintaining one paper, and on that their seats are marked by with a pencil, and whoever is being booked a seat, that will be marked an into, that is a cross mark. So if that is the situation, and they need to go for a product, and they need one reservation system. So the status quo is this. So that means what is that they are having? They are maintaining one paper kind of sheet, and on this they are doing some manual work. And with respect to this, I need to convert this manual things into the programmatic definition, a problem definition. So what I need to convert this, I need to convert this into a problem definition, like say a bus reservation system. So wherein an user can be allowed to log in into it, and he can perform, he can select the bus, and he can book the seat, or he can change the seat, or he can postpone the he can postpone the journey date, or he can cancel a ticket. So like this, what I need to do, depending upon the current work, I need to define the definition. So that definition should reflect the actual work of the status quo. And from this definition, I need to implement, right, I need to implement the technical technical aspects, like say what are the softwares that I need, right, what are the databases are related to the software. We'll discuss that in detail later. So that definition should be high levelly coded and low levelly coded in order to achieve our definition, or to